So what's good, TMG fam? Listen, we back with another interesting video, man. And this one seems to have scientists stumped, right? They're saying Saturn is changing and it's not good. So we need to see what's going on here. You know what I mean? But before we get to the video, man, and the madness and the craziness, if you're new, hit that subscribe button, join the family, and make sure y'all spam that like button. That's it. Let's get to the craziness.
Deep within the solar system, some 880 million miles away from Earth, a baffling world spins gracefully that has captivated the hearts and minds of astronomers for centuries. Welcome to the enigmatic realm of Saturn. The gas giant is full of secrets, from an artificially looking hexagonal pattern at its north pole to mysterious downpours falling on Saturn from space. And just recently, scientists noticed something weird was happening to Saturn's rings, which made them worry about our cosmic neighbor. In the very distant future, whoever inhabits Earth will not see Saturn's majestic rings. But why do astronomers think they're about to disappear? And what are these strange things moving along Saturn's rings? The first close-up images of Saturn, captured by the Pioneer 11 spacecraft in 1979, marked the beginning of our journey towards understanding this celestial giant. But it wasn't until the arrival of the Cassini mission in 2004 that scientists started to reveal the true wonders of this ringed world. As we continue studying Saturn, occasionally the planet unveils its secrets, demonstrating how much we still don't know about its intricate nature.
Exactly. I think one of the most mind-blowing things I came to realize or find out or discover about Saturn was the rings. Knowing that that's a lot of debris going around. You know what I mean? Have you ever seen it? Take a look at it or type in or Google search Saturn's rings and see what pulls up, man. I think that was the most mind-blowing thing because it just always was like, it was either, I always thought it was either gases or just beams of light that surrounded that growing up. I never knew what all it actually really entailed though. Interesting though.
Saturn is the solar system's second largest planet, and it has a core about half the planet's radius, which weighs around 12 to 20 times the mass of Earth. However, the amazing thing is that it would float in water if you had a big enough reservoir to hold it. This is because the gas giant's density is about 0.687 grams per cubic centimeter, which makes...
I think that's interesting that they said it would float in water. Now, what's the conspiracy theories we've been hearing people talk about? That space is water, like it's water above us and water below us. That's the new, I ain't gonna say it's new. I'm just finding out about those theories about water. So it's interesting that they said that.
Is about 0.687 grams per cubic centimeter, which makes Saturn the least dense amongst the planets of the solar system. But it's not just that. While most other planets orbiting the Sun appear as nearly perfect spheres, Saturn is the flattest of them all. Its orbital period is approximately 10.5 hours, and it spins remarkably fast, which makes the gas giant bulge at its equator and flatten at its poles. The ringed planet measures approximately 75,000 miles in diameter at its equator and spans around 68,000 miles from one pole to the other. Saturn's distinctive yellow and gold bands visible from Earth are caused by superfast winds in its upper atmosphere that reach an incredible 1,100 miles per hour. But if you were to closely observe the sixth planet, you'd spot something truly bizarre. A colossal hexagon pattern spanning about 20,000 miles in diameter. This awe-inspiring hexagon, with its immense proportions, might initially give the impression of an intricately crafted megastructure. Adding to its mystery, the pattern is transitioning from a bluish shade to a golden hue. Cassini's high-resolution images were carefully compiled to produce a breathtaking animation.
What is that? Could that possibly be a storm? What is that?
Revealing this phenomenon in vibrant color for the very first time. Within the swirling vortex of the hexagon located at Saturn's north pole, a colossal hurricane takes place in the middle, with an eye that surpasses Earth's hurricanes by a staggering 50%.
I thought that's what it was. Could you imagine? Jeez. And we think what we have to deal with on a year-to-year basis is something. You see the sheer size of that? And they talking about inhabiting some of these other planets, man. Do you know what we could potentially have to deal with?
Located at Saturn's North Pole, a colossal hurricane takes place in the middle, with an eye that surpasses Earth's hurricanes by a staggering 50%. Reddish vortices are scattered all around the hurricane. Together, they swirl in harmony with the counterclockwise motion of the hexagonal jet stream. Inside the hexagon, there's a notable difference in the composition of particles compared to outside. Within the hexagon, smaller haze particles are abundant, while larger particles are scarce. And outside the hexagon, the situation is reversed. One of the most intriguing aspects of this six-sided storm is its resilience. While hurricanes on Earth last merely a week, this remarkable hexagon has endured for decades, or perhaps even centuries. So, how does a monster storm like this form? A computer simulation revealed an intriguing phenomenon known as deep thermal convection. When heat is transferred through fluid or gas movement, it can generate atmospheric flows that result in the formation of large polar cyclones and an eastward jet pattern at high latitudes. As these atmospheric features combine near the planet's upper regions, they give rise to the unexpected and distinctive hexagonal shape observed at Saturn's North Pole. And the hexagon's persistence is the result of all these storms forming deep within the planet, thousands of miles below the cloud tops. Scientists don't know of any other storm like this to exist anywhere in the universe. Saturn's hexagons are a demonstration of the wonders of our universe is capable of, but it's not the only intriguing feature the planet has to offer. When looking through Voyager's data, scientists noticed something odd: mysterious spokes across the planet's rings. But then something even stranger was discovered. During the Cassini mission, no signs of these ghost-like features were detected, deepening the mystery behind this unexplained phenomenon. A closer observation revealed that the spokes generally have a dark appearance when viewed from above. However, when observed from below, they tend to appear bright. Researchers still don't know for certain what causes these mysterious streaks, but we do know that they re-emerge seasonally during Saturn's spring and fall. Just like here on our planet, there are 4 seasons on Saturn, but each of Saturn's seasons last approximately 7 Earth years. The spokes are hypothesized.
Oh, a 7-year winter? Listen, man, if we have the option to choose which planet we want to inhabit or go visit, or Saturn is going to the bottom for me, man, unless we go during that right time. We catch one of those seasons. You know what I mean? What's your favorite season? I would say maybe more aligns the spring-ish, right around that area. You know what I mean? Maybe fall. Those two. But winter and summer for 7 years? And I'm thinking about these Georgia summers, so we don't even know what type of planet summers they may have. But goodness gracious, 7 years, bro. That's different. That's definitely different.
And seasons last approximately 7 Earth years. The spokes are hypothesized to originate from dust particles in the rings that separate from icy chunks and float independently above the rest of the icy boulders. And it might be Saturn's magnetic field that causes this. When the solar wind interacts with Saturn's magnetic field, it creates an electrically charged environment. This environment can influence the behavior of the charged dust particles, making them stick together temporarily and form denser patches within the rings. Although other giants in our solar system also have rings, Saturnian rings are the largest and most distinguishable. The 7 rings were named in the order of their discovery. Positioned along Saturn's equator, the rings begin approximately 4,300 miles from the planet's core and stretch outward for a staggering distance. The E-ring alone encompasses a distance of about 75,000 miles to 260,000 miles. To give you a sense of scale, imagine a road extending across the entire length of Saturn's E-ring, from its outer wisps to the inner boundary. If you were to drive continuously at a speed of 100 miles per hour, it would take over 2.5 months to travel from one end of the road to the other. And if you take into account the tenuous Phoebe ring, it extends approximately 100 to 270 times the radius of Saturn. Much like the distinctive shape of the planet itself, Saturn's rings are incredibly flat. Detailed observations indicate that while certain areas of the rings can reach a thickness of approximately 0.6 miles, the main rings are astonishingly slender, measuring a mere 32 feet in thickness.
See, that's why we got to figure out this whole speed of traveling at the speed of light thing. You know what I mean? We got to figure out a way, because that's going to be our issue with moving around in space. Whenever we start to be able to move around consistently and freely, it's going to be how long it takes to get from one place to another, planet-wise, or to get past the rings on Saturn, to get to Saturn or anywhere else. It's that time factor, bro. It takes you like a lifetime just about to get from one place to the other.
Saturn's ring particles have a wide size range, spanning from minuscule icy grains resembling dust to substantial fragments comparable in size to houses. And there are even a few exceptional particles that reach dimensions the magnitude of mountains. But we didn't always know about Saturn's rings. Nearly 4 centuries ago, when Galileo first directed his telescope towards Saturn, he described the gas giant planet as having ears or handles, which were in fact the elongated bulges that we now recognize as Saturn's magnificent rings. With his modest telescope, Galileo could not discern the intricate details of the rings, leading him to mistake them for large celestial bodies positioned on either side of the planet. Today we think we know almost everything there is to know about the mighty rings of the 6th planet, but it continues to shatter our expectations. The particles within Saturn's rings, which are almost entirely water ice, are engaged in a delicate equilibrium between 2 opposing forces. Saturn's gravitational pull attracts them towards the planet, and their orbital velocity strives to propel them outward into space. Scientists have long wondered whether the planet evolved with its rings, and the latest findings show Saturn hasn't always had this peculiar feature. For more than 90% of the gas giant's lifespan, the planet had no rings. So how and when did they form? One possibility is that the rings originated later in the planet's existence, when small icy moons orbiting Saturn collided with each other. These collisions might have been triggered by the gravitational influence of passing asteroids or comets. A 2016 study proposed another intriguing idea, that the rings could be the remnants of dwarf planets. This theory suggests that these dwarf planets, which met their demise in the distant past, now exist as the enigmatic rings encircling Saturn.
Okay, well, let me stop saying space debris then. I mean, you got planets up in the rings of Saturn. Wow, like I always thought it was just, debris, rocks and different things like that. But now they're saying planets.
Or it could have just been one large moon that collided with Saturn's largest satellite, Titan, in the past. Scientists have identified a potential moon called Chrysalis that existed before Saturn's rings formed. Through computer simulations, they found that Chrysalis was similar in size to Saturn's 3rd largest moon, Iapetus. In the past, Saturn and Neptune's gravitational interaction caused the ringed planet's axis to tilt and wobble in sync with Neptune's orbit, leading to the changing angles at which we observe Saturnian rings. Titan exerts its gravity on the planet and moves away from it rapidly, while our moon also moves away from Earth, but at a slower pace. Around 100 to 200 million years ago, Titan and Chrysalis entered into a resonance, and as Titan migrated outward, the gravitational forces destabilized Chrysalis's orbit. That caused Chrysalis to approach Saturn and get torn apart by its gravity. Nearly 99% of Chrysalis was absorbed by the gas giant, and the remaining 1% left behind the stunning ring system we see today. According to a recent study, the age of Saturn's rings is approximately 100 to 400 million years, but their existence may soon come to an end. A true celestial marvel causes Saturn's majestic rings to melt away, and in another 100 or so million years, they will disappear. Under the influence of the sun's radiation or plasma clouds caused by space rock impacts, the dust particles of Saturnian rings sometimes become electrically charged and disturbed. When this happens, the dust particles bind to Saturn's magnetic field, which then draws them inward toward the gas giant's upper atmosphere. As the gas giant orbits the sun, the planet and its rings tilt, which changes the amount of the radiation output on its inner ring layers and affects the intensity of the icy ring rain. NASA says the 6th planet's ring system is depleting at an extremely fast rate. It's estimated that every 30 minutes, it loses an Olympic swimming pool volume of water. And just recently, after 4 decades of research, scientists have revealed the cascade of ring rain pouring down onto Saturn has an impact on the planet's atmosphere. Every passing second, an astounding amount of up to 6,000 pounds of icy particles previously bombarded by solar ultraviolet radiation gracefully descend onto the planet. As these particles make their atmospheric journey, their accumulated energy is transferred to the surrounding environment through collisions with other particles. This energetic exchange contributes to Saturn's atmospheric heating and may cause glowing bands in the planet's northern and southern hemispheres. But it's not the only rain there is on Saturn. Enceladus, a moon of Saturn, shoots jets of water ice into space from its underground ocean. Some of these tiny particles are influenced by Saturn's magnetic field and gravitational forces, causing them to rain down onto the gas giant's atmosphere. This phenomenon is known as the moon rain. Saturn's ring rain is a cocktail of chemicals, including some organic compounds. It consists of water, butane, propane, methane, ammonia, carbon monoxide, carbon dioxide, and molecular nitrogen. In the future, this cocktail could change the oxygen and carbon amounts in the gas giant's atmosphere. This alone isn't enough for any life to emerge on Saturn, but what about its moon?
Or our life going there, us eventually trying to go there and stay. See, these are the type of factors we got to think about, not just things that can happen inside of the planet, right? The gases that it already has there that you would be dealing with, but outside factors as well, coming from the rings, coming from space, the radiation, different things that can affect all of the gases that currently take place on the planet. So you dealing with a lot. It's a lot to take into account. I be seeing people online all the time talking about, well, what's the holdup? Why haven't we gotten started building and doing different things on Mars? What's taking so long? Is this just a money play? Are they just doing this to get funding and using the money for other things? It's like so many people wondering what's the delay. It's a lot of stuff that got to be taken into account. A lot. And you have to figure this stuff out over time. See how when certain things happen, like they're saying, Saturn is starting to lose some of its rings and stuff like that. How does that now affect the planet? You don't want to start building over there and then realize it's losing its rings, and now you have to deal with whatever is about to come your way that you didn't plan for. No. So will we see us living or inhabiting a planet in our lifetime? Probably not, man. We still haven't gotten together all of what could happen or take place on those planets that we're thinking about.
Moons. Just recently, Saturn once again became the king of moons of the solar system. 62 new satellites have been found orbiting the ringed planet, which adds up to a total of 145 moons. But to scientists, particularly intriguing are Titan and Enceladus. Both of these satellites possess at least one essential ingredient for life. Titan is known for its thick atmosphere and abundant organic molecules, including complex hydrocarbons, which are considered building blocks for life, while Enceladus has a subsurface ocean of liquid water, making it a promising candidate for hosting life or supporting the conditions necessary for life to exist. Titan possesses a dense atmosphere resembling that of a planet. Similar to Earth, its atmosphere is predominantly composed of nitrogen. Additionally, Titan has rivers, lakes, and seas on its surface. However, unlike Earth's water-filled bodies, Titan's liquid reservoirs consist of methane and ethane. Methane is a compound associated with the metabolic processes of many organisms, serving as a source of energy. Although it's highly improbable that the lipid-based membranes crucial for sustaining life on our planet would endure Titan's inhospitable conditions, such as its freezing temperatures of about -290 degrees Fahrenheit. However, scientists have proposed an alternative possibility involving a molecule called acrylonitrile. One of the unique properties of acrylonitrile is that it's potentially capable to form stable and flexible structures like cell membranes, forming a thin sheet-like material. This sheet could then shape into a small, hollow sphere called an azotosome. Similar to lipid bilayers, these azotosomes could act as microscopic containers for storage and transportation purposes. What's fascinating, the ALMA observatory has detected significant amounts of acrylonitrile molecules in Titan's atmosphere, up to 2.8 parts per billion. Scientists believe an abundance of this chemical reaches the surface of the satellite. Throughout the existence of Titan, researchers calculated that Ligeia Mare, Titan's lake, could have gathered sufficient acrylonitrile to create approximately 10 million azotosomes in every milliliter of liquid. To put this into perspective, it surpasses the abundance of approximately 1 million bacteria per milliliter of coastal ocean water found on Earth. Set to launch in 2027, NASA's Dragonfly drone will examine the satellite in depth and finally bring us closer to understanding whether life could form on such a celestial body. Until then, we might discover even more candidates for the existence of extraterrestrial life within our solar system. So stay tuned here to be updated on the latest breakthroughs in space exploration. We hope you...
Now, could there be some type of breakthrough in technology? We're hoping, you know what I mean? Like I was talking about with time, us trying to figure out being able to safely and successfully travel at the speed of light. You know, could there be a breakthrough in that? Possibly. Is there going to be a breakthrough in us inhabiting one of these places? I just don't think we have enough data right now. I don't. Saturn is very, very challenging. It's a lot that has to be taken into account. A lot. We're still trying to figure it out, see what we're dealing with. And that goes for a lot of these other planets as well. These things we're still in the beginning stages. You know what I mean? So just kind of pump your brakes a little bit. I have to tell myself that too, because I be wanting to see new things, new updates, you know what I mean? New progress. Every week I be wanting to see something new. And I have to kind of humble myself down and tell myself, all right, calm down. You know what I mean? This stuff is going to take time. So I get where you're at on that. You know what I mean? But y'all get at me in the comment section, man, and let me know what you thought of this video, man, and how Saturn is changing. Does it surprise you? Put it in the comment section. Stay around and stay tuned. Till next one, I'm gone.